So, I welcome you all to a discussion about ASM, which stands for the Automatic Storage Management. Here we will do an end-to-end discussion about the automatic storage management concepts and architecture, and then we'll practically configure it on one of our lab boxes. We'll configure ASM in a non-rack environment to get started off with. But before we actually go on to ASM as a concept, we need to understand certain prerequisites about our real life requirement and certain understanding as to how people use storages in real life. One of my basic requirement for a real life environment is my storage should offer me a file bigger than a disk. So assume that I have a couple of disks there with me. I would like to have my ASM give me a facility where I should be able to create a file which is bigger than a disk. Now when we talk about a SOHO purpose, small office, home office type of an environment, we typically use a disk as a disk, or at the max somebody would like to partition a disk and then use each partition as a disk. So you see individual partition as if it's a disk, but with this kind of an usage where you use disk as a disk or partition as a disk, the biggest limitation with this kind of a usage is the files that you put on that disk or a given partition are limited to the size of that partition or to the size of that disk. So a small office, home office kind of an environment doesn't offer you a storage benefit where you would like to create a file bigger than a disk. That is not possible. So we would like to use it in real life. The second thing is the IO throughput should be the best. When you use disk as a disk, or when you create a partition on a disk, you format it, you start using it, you keep multiple files on the same partition. Now since there's only one read-write controller or one disk cache available to you when you perform an IO operation, the IO operation is constrained by the capacity of that disk. So you don't get the best of the best throughputs available when you start using disk as a disk or partition as a disk. So that is one of the major limitations in a SOHO purpose. For critical data in real life, we want disk fault tolerance. By disk fault tolerance, I mean resilience against failures, against disk failure, which we normally don't get in a small office, home office kind of an environment. Assume that you had a disk which you formatted and we are accessing as, say in case of Unix, a mount point U008, or as D drive in case of a Windows usage, and assume that the disk has failed. Until there's a backup available for the data, there's no online resilience available for such a critical loss of data. If the disk fails, whatever was there on that disk, everything is lost. Now the only way you can restore back that data is to have a proper backup strategy in place and then restore it back by replacing the disk with a fresh one and restoring that data from your archives, from your backups. But any small office, home office kind of an environment doesn't offers you online resilience against a disk failure. So if a disk fails, the failure should be transparent. My application shouldn't see that failure. This doesn't happen in a small office, home office kind of an environment, which is highly desired feature of a production implementation. In a production kind of an environment, you don't want any downtime just because your disk has failed, because implementing a fault tolerance is less costly than the downtime it costs if you don't implement a fault tolerance. So this kind of a feature is highly desired from a production system. In a clustered environment, we need a cluster file system. A cluster file system gives you ease in performing daily operations. Otherwise, you need to work with raw devices. If you want to implement a cluster environment, in a clustered environment, since two or more nodes are sharing the same shared devices, storage devices, you need an intelligent file system. That intelligent file system is normally there for ease of operation. If you do not have a cluster file system option available with you, then the only choice traditionally that has been available to you was to use raw devices. But the biggest problem with raw devices is with raw devices, there are high admin costs and then an explicit planning is required. The biggest problem with a raw device is a raw device can hold only one file at a time. Since it holds only one file at a time, the estimation about your so-called future requirement should be explicitly stated and there should be a proper planning process. Otherwise, assume that I allocated a 10 GB of a raw partition or a raw device, assuming that my file is going to grow to 10 GB limit, but my file never grow beyond 2 GB in my environment. Rest of the 8 GB space cannot be reclaimed back. It's all a wastage of space. So there are high admin costs implementing raw devices, and there's explicit planning required. And mostly in a conception phase of your database implementation where things are not crystal clear, this may often lead to over allocation or under allocation. Now, over allocation of a space on a raw device is a space wastage, and under allocation is a addition in the admin cost because you need to allocate too many such raw devices because your planning has failed. So we want to use instead a cluster file system where you get a mount and you can put multiple files, several files on a given mount point. But then cluster file system is a licensed component. You need to pay for additional licensing. IO load balancing is normally an activity driven by a personnel. Now assume that I have 4 different disks that I am using, starting from say U006, U007, U008 and U009, and then I placed certain files, some n number of files here, some n number of files here, and I have distributed my database load across 4 different disks to utilize maximum IO bandwidth available with me. Over a period, I discovered that this disk is the hot disk, while remaining disks are either cold or warm in nature. This is in terms of the IO. So some of the disks are experiencing high IO, while others are sitting idle. Now whenever you come across this situation, ideally from the hot disk that has been identified, we move couple of files from that hot disk to cold disk, which is a manual activity. So number one, somebody needs to give you those statistics that one particular disk is more utilized than others. We normally monitor those disks using iostat Unix command or sar Unix command. And once we figure it out that a particular disk is experiencing high IO than others, then it comes to a DBA. DBA would relocate couple of files from that hot disk to the cold disk in order to balance the IO across the disks. If the IO isn't balanced and you see only a couple of disks are hot while others are cold, that means you are not utilizing the complete IO bandwidth available to you. While the IO is being queued for hot disk, it is no longer getting any IO request for cold disk. So which is suffering at an IO bandwidth utilization level. So whenever it comes to doing any IO load balancing, it used to be normally an activity. It used to be normally an activity which was driven by personnel, combinedly by your Unix admin and by your DBA. There isn't any intelligent mechanism so-called built into your operating system where it would try to balance the IO no matter how you place your files onto those mount points. Your operating system cannot make an intelligent decision. Your operating system cannot move them transparently without letting the user know that it is trying to balance the IO. It is all an activity driven by personnel, which automatically means there are high admin costs. So the maintenance cost, the upkeeping cost for IO load balancing is high if you implement it using a cluster file system, if you implement using different multiple mount points. Traditionally, whenever it's a clustered environment, raw devices are preferred. That is because there is no IO caching. And whenever there is no IO caching, the performance given by such devices is good compared to block devices. So block devices doesn't offer you as good performance as could have been offered to you by raw devices. So traditionally, the only way to implement a cluster where IO requests are coming from more than one computers were possible only when you use raw devices, which for ease of use, raw devices were replaced by cluster file systems, because people don't want to work with those clumsy raw devices because there are more chances of accidents. There are more chances that you would spend huge amount of money in upkeeping the raw devices compared to a so-called new revolution in the industry called as cluster file system. So you have a shared disk, format it with a cluster file system. Now you get one mount point, but then you can keep multiple files on, which is not the case with raw devices. Because of multiple such disadvantages in a so-called implementation in real life, which is nothing but an added cost if you want to have that so-called premium feature, Oracle was forced to bring in a technology change, and that the technology change is ASM. So when it comes to storage should offer me to create a file bigger than a disk, people used to implement either or. They would either implement it via RAID level 0, which is striping, or volume manager. The volume management concept in Linux we call it as LVM, logical volume management. This offers you whatever is required in point number 1. So you club multiple disks together, put them in a RAID level 0 grouping. Now the total space available to you is the combined space of all the disks. Now since it's a combined space available to you, you can create a file which is actually bigger than the size of the disk. Or similar thing could have been implemented using a volume management concept, which I am going to explain with a diagram shortly from now. I want best IO throughput. Typically we implement via some RAID level 0 and or logical volume management. This can be achieved either by putting multiple disks together in a RAID level 0 configuration or configuring disk in a volume. For critical loss of your data, you want your disk to be fault tolerant. We achieve this via some kind of a RAID implementation. Wherever it comes to ease of use, you want a kind of a cluster file system environment where there's no trouble to manage those individual raw disks. There's no explicit planning required. Typically, this was implemented using a cluster file system, and cluster file system is something that requires separate licensing. With raw devices, although the performance is good, but there are high admin costs involved. IO load balancing was a manual activity. Now to counter all these negative points of so-called traditional implementation, Oracle came up with ASM, which stands for Automatic Storage Management. Now all the requirements, so-called requirements that we listed, so 6 requirements, are fulfilled all alone via ASM. Before we move on to that, we will talk about how traditionally one could use a disk. There are two most common usages of a disk, or the way you use it. Procure a disk, install a disk inside your computer, optionally partition it depending on how you want to use it. So partitioning is optional. Format it with a file system of your choice. Mount the disk, mount the formatted disk. Start using it. This is the most common practice that we follow for small office, home office kind of an implementation. We take a disk, we install it inside a machine, we power it on, we optionally create partitions on it, you format it with some file system of your choice, mount that formatted disk, and then we start using it. So in a typical Windows scenario, you would install a disk, you would optionally create multiple partitions on it depending on your requirement. You would format that disk with some file system. In typical Windows case, it would be FAT or NTFS. In typical Linux scenario, it would be either ext2 or ext3. In case of AIX, it would be JFS or JFS2. In case of Solaris, it would be UFS or ZFS. So depending on the availability of file system choices on a given platform, you would format it with some file system. Once it is formatted, then the formatted disk is mounted, and then you start copying files under a given mount point which would go to that respective disk. Such a usage is called as cooked disk, because you have cooked it by formatting it. There's another usage which is not so popular in a small office, home office kind of an environment, but is often common in case of clustered implementation, called as a raw usage. Some of the points are common while others wouldn't apply. I'm going to copy that entire section here. We'll remove those points which are not required. So you procure a disk, you install it, you optionally partition it. What is not applicable here is these points don't apply. So you get a disk, you install it, you optionally create partitions on it and start using it. We neither format it. Since they are not formatted, there's no file system on top of that partition or on that particular disk. You directly cannot mount that because there's no file system on it. So we start using it as raw. Now I'm going to show you a couple of differences between a raw file and a cooked file. In case of Unix implementation, which is where our most of the focus is, here I want to first find out what all disks I have. I say fdisk-l grep, find out those disks. I have a lot of them there. If you see, I have SDA, SDB, SDC, SDD, SDE, SDF, but for some of them it says they do not contain any partitions. While SDA is having multiple partitions, this from B to F, SDB, SDC, SDD, SDE, SDF does not contain any partition as of now. If I want to further see how my SDA disk looks like, because it says it is partitioned, I can see multiple partitions there. So those partitions are listed here as /dev/SDA, S1, SDA2, SDA3, 4 and 5. So I have created this disk which is of the capacity approximately 86 GB with multiple partitions. While other disks which are listed from SDD to SDF, SDB to SDF does not contain any partition. To prove it, we say fdisk-l, name of the disk, and it says the device does not contain any valid partition table. Now when I see what kind of a device is this, or what kind of a device is this, they are all block devices, which is listed here with the first character indicating that it's a block device. So most of the time when you use this, we use it as a block device. We don't use it as a raw until there's a special purpose like a clustered implementation where a raw disk is desired over a block implementation. So only in that case you go with a raw implementation. We do not have any raw device as of now, which we are in the process of creating. That time I would show how you can distinguish at an Unix level a block device from that of a raw device. Coming back to how things are different in case of Linux. Assume that I have Solaris installed and then I attach a disk. The disk was detected by my Solaris operating system as CN, TN, DN, SN, where N is some number, where it identifies C as the controller, T as the target, D as the disk, and S as the splice. Splice in case of Solaris means a partition. So CN which controller, TN which target, DN which disk on that target, and SN where S is the number of partition on that particular given disk. If you see ls-l of this disk, it is block in nature. But Solaris does also creates an alternate name for a disk, and that would be RDSK, CN, TN, DN, SN, again where N is some number which identifies the physical location of the disk attached within your server's assembly. But my point here is it gives you both names for an attached disk, a block device name and a raw device name. Same is the case with AIX. If I attach a disk on an AIX machine, then AIX assigns two names for that particular disk. So one is block name, which is dev h disk n, where n would be some number, and dev rh disk n, which is the raw usage. But the biggest problem with Linux is when you attach a disk to the Linux machine, Linux has long deprecated support for raw devices, so it only assigns a name in this format, SDX, where X would be SDA, SDB, SDC, SDD, and so on, depending on where exactly to that particular SCSI disk is connected inside your machine. Meaning, there's no raw device name assigned by Linux because raw is deprecated. Well, now that the raw is deprecated in Linux, where actually is Linux heading? Linux found out that there's a new API using a O direct call, which is more efficient So Linux says you start using block devices, but if you want to use them as if they are raw, start using ODirect API at an OS level. ODirect is a flag that you pass while performing an IO on a given device. So that's why Linux doesn't natively give you any facility to create by default raw devices. That doesn't mean Linux does not have raw devices. In Linux, if it is still required, you can still create raw devices, although kernel doesn't natively supports them. So when kernel doesn't natively supports, there's a utility called as raw devices service. So it's no longer a kernel built-in feature. In fact, it is a new service that offers you still creation of raw devices, and that raw devices service allows you to create raw devices in Linux. So it allows you to create still raw devices, although kernel doesn't natively support raw devices. But there's still an option available for you to create raw devices, and that you can create it using the raw devices daemon, the service. I get back to my Linux prompt and say services raw devices status. I don't see it as of now, but when I go to ntsysv to see what all the services there I have, I do see there's a service called as raw devices, and that it is up and running. So Linux does offers you creating raw devices. Okay, so now that we have Linux posing its own challenges about creating raw devices, we need to understand how to implement ASM. For ASM implementation, ASM requires on all other Unix platforms raw devices. But since Linux has deprecated them, ASM can still either you implement raw devices, although they are deprecated using the raw devices daemon, or start using block devices for ASM implementation in case of Linux using ASMlib software.
Video of this session.
So only in case of Linux where raw devices are deprecated, ASM can still be built using block devices, but in that case you will have to implement ASMlib software. Now ASMlib software So this is the utility provided to you by ASMlib. So it's ASMlib is a kernel version specific software. In case of Linux, it comes to you in the form of RPMs, Red Hat packages, which allows you to using block devices for ASM implementation. So on any other Unix platform, ASM is built using raw devices. On Linux, if you want to go beyond and create raw devices, you can go give those raw devices to ASM. But the preferred method in case of Linux is to use block devices using ASMlib and then use those block devices for your ASM configuration. Is the preferred way. That doesn't mean you cannot create using raw devices ASM implementation on Linux. It is possible. But the so-called best practices suggest use ASMlib as a software. I'm getting back to my presentation to just do a quick recap. So this is how it looks as a technology stack. You have operating system, you have volume manager functionality, then you have some kind of file system. It is typically a cluster file system. Now you either go with this traditional implementation or discard these two things off and go with ASM implementation. And then on top of this, build your database and let those applications access your database. Your database in this case has implemented its files onto the ASM. They are no longer being kept onto the volume manager. They are no longer kept onto your file system. So this is how on the left hand side, this method is the traditional method and this is the new starting from 10G and ASM, how it could substitute to the so-called traditional solution of volume management and file system based implementation. I'm getting back to our ASM discussion again. So when it comes to ASM implementation, what we need I want a disk group. That disk group is made up of raw devices in turn. So this is my raw device 1, this is my raw device 2, this is my raw device 3, and you always have a possibility to keep on adding raw devices because your space requirement is going up. So this is that whole big thing is called as a disk group, that black portion, and each of those white boxes indicates a raw device. So you take together multiple raw devices, you put them in a container, a collection. That collection is called as a disk group. So at an ASM level, ASM disk group is made up of or is a collection of raw devices. Now this disk group is managed by ASM instance. So ASM instance, like your RDBMS instance, to just be clear about what I mean by ASM or what I mean by instance. Instance is a collection of memory and background processes. So whether it's ASM instance or an RDBMS instance, there's no distinction between an instance from an instance standpoint. An instance is a collection of memory and background processes, and this memory allocation and these background processes are then responsible for managing IO operations or the upkeeping of your ASM disk group. Finally, an ASM disk group is nothing more than a collection, a passive or an intelligent collection of raw devices. Now once you have this ASM disk group, see how we organize them. I have prepared a disk group and then I am organizing disks inside it. I had say one disk. So assume that the total capacity of my disk is say 20 MB or say 20 GB for ease of references. I said I have a disk, raw disk of 20 GB inside my ASM disk group. So the capacity of my entire ASM disk group is 20 GB. But now assume that my space requirement is going higher. I keep on adding multiple disks of whatever capacity, not necessarily 20 GB. I added another disk to a disk group. Now the total capacity available with my disk group is 40 GB. I need more space. I keep on adding disk to my disk group this way. Now the total capacity available inside my disk group is 60 GB. What an end user or a DBA is bothered about is how much space is available inside a disk group, and what we are not bothered about is how many raw devices are there. So you no longer care about how much space is available in a raw device. You are bothered about how much total space is available at a disk group level. Now assume that I have a disk group which is created out of 3 20 GB disks. So the total disk group capacity available to me is 60 GB disk group. Can I not create a 30 GB file now on a disk group which gives me 60 GB of a storage space? Yes. Now that I can create a 30 GB file on a 60 GB disk group, this is exactly what we were looking for. Storage should offer you to create a file which is bigger than a disk. Now your disk is actually 20 GB, but you are able to create a 30 GB file. How is that possible? Because we are no longer bothered about the independent raw devices. We are only bothered about how much space is available inside a disk group. And disk group gives me 60 GB space. I no longer care how ASM stripes that data internally onto those raw devices. My file is stored onto each of those participating raw devices. So first advantage is there that you can now create a file which is bigger than the size of a disk. Now I can create on a disk group of 30 GB file where each participating disk is actually a 20 GB container. But since I have a 60 GB of a space at my disposal, I can always create a 30 GB file on a 60 GB space. So the data internally is getting striped like red level 0 onto each of those participating disks. Second one, what we wanted is the IO throughput should be best. In normal use, you use a disk as a disk or partition as a mount point. Then you keep storing files on that. Since multiple files are going onto a single disk, the IO bandwidth is limited. Whatever is the disk IO cache buffer is limited because you are using one disk, and there are high chances of IO contention because multiple files are going onto the same disk. See how things are different here. Now when I store a file on this particular disk group, I am not storing it on raw, I am storing it on a disk group. The file gets divided into multiple pieces, and those pieces are then stored onto each of the participating disks in a striped manner. So assume that I want to store a 100 MB file on this particular disk group, and that the disk group is made up of 3 disks of 20 GB each. And when I add a file, this is how the file would be stored. The data is striped, the files are striped, and then once those stripes are available to you, those stripes are then spread across each of the participating disks. So assume that I'm getting back to my diagram. Once I have decided to store a 100 MB file on this disk group, the file is divided into multiple small pieces, and those pieces are then stored, a couple of them here, a couple of them here, and a couple of them here. Now when you perform a bulk IO operation on that file, assume that you are doing a full read of that entire file. How many disks will come into picture? 3 disks. So traditional usage where one disk stores multiple files, you get exactly opposite of it. One file is stored onto multiple disks. So when it comes to doing IO, all of that IO bandwidth provided to you by 3 disks can be utilized at the same time. So obviously when files are striped, you get this advantage. And the advantage is, in case of striping, IO throughput is good. This is exactly what we do in case of RAID level 0 implementation. You take two disks together, put them in a RAID group 0 configuration. The total space available to you is now actually whatever is the space offered to you by disk 1 and disk 2. Whenever you store something onto RAID level 0, the data gets striped. Partial data is stored onto disk 1, partial data is stored onto disk 2. Is what is the advantage of RAID level 0. Same thing is also offered to you by volume management. Now volume management is something is to be implemented at a OS level, is implemented this way. In case of volume management, I need to draw a separate diagram though for that purpose. And to open another paintbrush session. So where you don't want to use disk as a disk, at an OS level you can implement volume management functionality. So what we do, we take disks, actual disks. Since actual disk usage is different than the volume management thing, we need to do a special activity here. So I have taken multiple physical disks together. Once when the disks are available, I cannot make use of those disks as is. I need to erase off the independent identity of the disk. This we do via a process called as converting them to PVs. So we convert each of these disks to something called as PV. PV stands for physical volume. So I converted off those disks into something called as a PV, physical volume. Physical volume exactly would be of the size of the disk because each disk is converted to a PV. Then we add all of those disks into an aggregation. That aggregation is called as VG, volume group. Then the available space is allocated as per your requirement to actual volumes. They are called as LVs, logical volumes. The space is allocated from the volume group. Now assume that once this volume group was available, I mounted it as /U008 and this was mounted as say /U007. Now when I copy files under U008, can you tell me onto which disk it is going? No. So it is all called as a storage virtualization. So I kept my files under U008. Let's assume that each of these participating disks are of 20 GB each or say 25 GB. Then the total space available to me in a volume group is of 100 GB because 25 disks, 4 disks of 25 GB each. The total space available in a volume group is 100 GB. I allocated 60 GB here and remaining 40 GB here. Now once I have a space of 60 GB, can I not create a file of 30 GB on that 60 GB mount points? But is that file going to one disk then? Because each disk is of 25 GB. So when you store a file of 60 GB here, the data is actually striped and stored onto each of those physical volumes. Physical volumes are nothing but the representation of your actual physical disk. So this is the benefit that we get using a volume management concept. Now the same thing using a different terminology is what is offered to you by ASM. So I'm going to close up this one and would explain how it is synonymous to ASM. Now whatever was available to you in case of a volume group is what exactly is offered to you by a disk group. So disk group is a collection of multiple physical raw devices. That is what exactly you were getting when your volume group was made up of PVs, physical volumes. So now when I store data onto my disk group, I don't care where exactly the data is going. The contents are striped. Those striped contents are then placed into each of the participating disks, is what is offered to you by an ASM disk group. To take it to a further level, we need to understand what kind of a striping it does. So whatever goes is striped. Whatever you store on ASM disk group is striped. Now what kind of a striping methodology ASM applies? Each piece of storage allocation on ASM disk group is counted in terms of AU. AU stands for allocation unit. For data files, ASM applies core striping method. By core striping, we mean each AU is of 1 MB in size. So when it comes to data files are divided into multiple smaller pieces. Each piece is done using a core striping method where allocation unit is of 1 MB. So if I store a data file of 100 MB size on a disk group, on a ASM disk group which has 3 raw devices, then 100 pieces of 1 MB each are sprayed. So whenever you store a data file of 100 MB, then the data file is divided into 1 MB pieces. You will get such 100 pieces, and those 100 pieces are then evenly stored across all the participating disks in that disk group. But when it comes to control file, redo-log file, each AU in that case is of 128 KB. So when you store control file or a redo-log file on an ASM disk group, then each AU is of 128 KB, and such method is called as fine striping. So data is being striped using a fine striping method, because that the IO characteristics of a data file and that of a control file and redo-log file are different. In case of data file, we do bulk IO, but in case of control file, you don't write bulk data at a given time. Same is the case with redo-log data. Redo-log files contains redo buffer entries which are periodically flushed. So you don't write bulk writing. You don't do bulk writing in case of control file and in case of redo-log. So the stripe size selected for control file and redo log file is 128 KB striping. It's called as a fine striping method. So if I store on our ASM disk group now a control file, the control file will be of 128 KB pieces, and those pieces are then distributed across all the disks. So what each disk gets in turn is either 1 MB piece like this, or a 128 KB piece like this, and those pieces are then spread across each of the participating disks. The biggest limitation of a raw device is that one raw device can hold only one file at a time. This is the biggest limitation. Since it does not have any file system, it does not have inode table or file allocation table. So there's no way in the world you can figure it out where one file is ending and where other file begins. So that's why with a raw device, you can store only one file at a time on a raw device. But when it comes to, in case of an ASM, it gives us an illusion that although I have added a couple of data files, a couple of control files, a couple of redo log files, and total number of files say is 6 in my case that I have stored, but there are 3 raw devices only. So technically speaking, this shouldn't have been possible because each raw disk allows you to store only one file. But for you as an end user, you are not storing the files on a raw device. You are storing it on a disk group. So if I examine each of these raw devices under microscope, then there's only exactly one file on that raw device, and that raw device has only one file, and that file is called as ASM file. So those raw device has actually one file, and your files that you store in a form of a striped manner is stored as a contents of that ASM file. So what it gives you a feeling that I was able to store say 6 files on 3 raw device disk group, but it is not that case. So each raw device, assume that I am talking about this raw device, each raw device exactly has only one file inside it, and that one file is your ASM file. So let my shaded black portion indicate the raw device, and let that white portion indicate the ASM file. So whenever you store your data files, whenever you store your control files, whenever you store your redo logs, depending on the AU, I assume this is of my 1 MB AU, and let this be of 128 KAU in case of fine striping for control files and for your redo logs.
So it internally recognizes the
Yes.
distinction between
Yes,
redo log,
exactly.
and we get rid of the earlier tradition of stripping, right?
Yes, no more manual striping. ASM can do it all on its own. All of them are going into the same file. Since you don't know now which AU belongs to what kind of a file, there's no way in this world without an ASM instance you can access that data. Because now only ASM knows which disk contains what AU and that what AU belongs to which file. So there's only way to access this data on that ASM disk group is via ASM instance, because now only ASM instance knows that how it has magically distributed that data on that disk group. So now I don't know which piece belongs to where. So this is only now known via an ASM instance, which is a set of memory and background processes. So this is how things are. So but it gives me an illusion that I was able to store a couple of data files, control file and redulog file all on the same disk. How is that possible? That is not possible technically, because a raw disk can hold only one file, and that the only file is ASM file. All your contents, all your stripes, whether it's a coarse stripe of 1 MB or whether it's a fine stripe of 128 KB, are all going into the same ASM file. Clear?
If we have ASM instance for storage will be single, right?
Yes, it's always a single
If
instance.
we have multiple databases,
Then single ASM instance can cater to those databases. We'll come to that analogy of what is the relationship between all of them. Now, if you see exactly what kind of an architecture is this ASM and RDBMS instances, is this clear? Then it's a client server kind of an architecture. I will get back to that, do remind me. Now, when I have connected this disk in a raw devices in a ASM disk group, by default there is no fault tolerance until you say so. So all these disks are part of the same disk group. So if one of my disks fails, entire disk group fails. So there's no fault tolerance. In such an organization where I don't subdivide my disk group into smaller groups, such a kind of an organization is called as such a implementation is called as external redundancy. So this example is of external redundancy. So I have not further subdivided that disk group into smaller groups. So if one of the disks fails, so assume that one of my disk has failed, then entire disk group has failed. Because there's no way you can reconstruct the data on that failed disk group. That's why such an engagement where a ASM disk group is not further subdivided into subgroups, it is called as an external redundancy. It is called as external redundancy. So external redundancy does not offer any fault tolerance. So there is no fault tolerance offered to you. But we are talking about critical systems. We are talking about critical systems where you can't afford to lose data. So in that case, we need to further subdivide it onto multiple groups if you are looking for resilience against the failure. So in this case, what I can do is I can further subdivide these disks into two or more groupings. Assume that in this case I have divided them into smaller groups. Each of these smaller groups is called as a failure group. Say for that matter, I would name it as FG1, FG2 and FG that way. I will call it as FGN. That replace that N with whatever number or character you want. So the ASM disk group is further subdivided into smaller group if you want for fault tolerance. Now see how the data is written into. Now whenever you store, so how many failure groups I have defined? 3 failure groups. So your ASM disk group can be further subdivided into smaller groups of disks called as failure groups. Now if you have two failure groups, it's called as normal redundancy. If you have three failure groups, it's called as high redundancy. Now both allows you fault tolerance. Normal redundancy allows you one master copy and one mirror copy, while high redundancy allows you one master copy and two mirror copies. So assume that I am talking about high redundancy. I have three failure groups defined here. When you write data now, assume that I am writing data. I would draw them as colored lines this time to avoid confusion. So if I store data onto this ASM disk group, now data is stored here, a mirrored copy is stored here, and another mirrored copy is stored here, because I am talking about high redundancy. So one master copy as a dark line and two mirror copies which indicate say a mirrored data. So mirror 1 and mirror 2. Now if this disk fails, we don't care. The data is transparently available through other mirrors. So there is no, so this kind of a failure is transparent to the databases. Databases cannot see such kind of a failure. So database will continue to be functional as long as I can access data from the other failure groups. So it's kind of a resilience against the disk failure. We want it for fault tolerance of disk, which traditionally was implemented using costly RAID controllers. Now you don't need to implement costly RAID controller, have all general purpose disks, just subdivide them into smaller groups called as failure groups. Data is automatically made redundant. I'm going to redraw it because now this is not going to allow me to erase off certain contents. Now this time I am drawing it a little different. I assume that I have a disk group. This time I have just two disks, or rather four disks I would say, and I would club them into I'm deliberately taking them of unequal size. This time I have divided them into just two failure groups, FG1 and FG2. Whatever data then is stored here is actually mirrored on this failure group. Now this can be of unequal sizes. As long as the contents can be redundantly written onto the other failure group, it's okay. So it's more intelligent and practical than RAID level 1, which is disk mirroring. In RAID level 1, you need two disks of equal sizes. Here you don't need all disks to be of equal sizes. They could be of uneven sizes, but the total space offered to you by failure group 1 should be equal to total space offered to you by failure group 2. Doesn't matter if there are three disks here of unequal sizes and which mathematically equals to two disks on the other side. As long as the total capacity is same, Oracle would ensure that if it writes data here, it mirrors them here. No matter whether there are three disks on one side and four disks on the other. The total capacity should be a mirrored capacity is what we need. So FG offers 60 GB space, this FG offers 60 GB space. This 60 GB offering comes via 3 disks, while this 60 GB offering only comes via 2 disks. It doesn't matter. So it's intelligent than RAID level 1, which is disk mirroring. Here it is failure group mirroring. So whatever data is written here it's mirrored to some other disk onto some other failure group. So when your disk group is divided into two subgroups, it is called as normal redundancy. And for high redundancy, it requires three failure groups. Failure groups is the subdivision of a disk available inside a disk group. Clear? Now, like any instance, ASM is also an instance, although to distinguish from RDBMS instance, plus ASM would be the name of that ASM instance. That plus sign is to distinguish it from the RDBMS instance. Since we are talking about an instance, so startup shutdown process also applies to an ASM instance. So is the parameter file. So obviously the name of those parameter file would then be, depending on whether you implement an P file or an SP file, name would either be init plus asm.ora or SP file plus asm.ora. But one good thing about ASM instance parameter file is there are only a finite number of parameters, a very limited set of parameters. The first one is instance type. This parameter also applies to RDBMS instance. Default value for this parameter is RDBMS. That's why you don't mention it in case of regular RDBMS instances. But in case of ASM, the value is instance type as ASM. This is how your instance is distinguished from an RDBMS instance, that this is a special purpose instance. You can give a value for ASM power limit parameter between 0 to 10. We'll talk about what is that ASM power limit. Now assume that I have a disk group, I have an ASM implementation. I implemented a disk group with two disks. In this case, data was written. The disks are somewhat full. I would partially paint them to show that they are partially full. Because ASM writes data in a striped manner, isn't it? So let this red color indicate the filled portion of the disk in your raw disk, in your ASM disk group implementation. Now you saw that there's the space free is within the warning limits. You decided to add a new disk to ASM disk group to augment the space. So you decided to add one more disk and you added it. The problem with the newly added disk is that it is empty, while existing disks are full with data. Now when it comes to doing I/O, the I/O would be making this disk more busier than this disk, because this disk doesn't have any data as of now. This doesn't happen in real life. The moment you add a disk to a disk group, ASM will migrate certain AUs, allocation unit, from the existing disk to the new disk, so that each disk experiences the same level of I/O operations. And what you would get at the end, I want to repaint it off. So ASM would migrate certain AUs from existing disk to the new disk. What you get at the end is equal amount of I/O. This is called as rebalancing. So this is called as IO rebalancing. Now what is the advantage compared to when we initially stated our requirements? That IO load balancing, which earlier was a manual activity where you used to relocate a couple of files from a hot disk to cold disk, is no longer required. ASM is intelligent. The moment you add a disk to an ASM disk group, it knows that now this disk is empty compared to others. So it migrates couple of AUs from existing disk to the newly added disk with an anticipation to balance the IO across all disks. So the chances of you getting certain disk hot, certain warm and certain disks as cold will never happen in case of ASM. IO is automatically balanced. Okay. Now that ASM does IO load balancing, who does it? So there are two special background processes for an ASM instance called as rbal and arbn. rbal stands for rebalancer, which is just a coordinator process, while the actual worker processes are ARBN, where that N ranges from up till 10 ARB processes. That's why this ASM power limit has a value between 0 to 10, meaning whenever the disk configuration changes, either when you add a disk to a disk group or when you remove a disk from a disk group, there must be rebalancing. Then at what level this rebalancing should be done? 0 means do not do any rebalance. When the disk group configuration changes, do not do any rebalance. Let it be as is. And any value between 1 to 10 means those relative degree of ARBN processes that you want to start. So 1 means have only one worker process to do that entire rebalance. If you say 10, there would be 10 ARBN processes which will migrate those AUs from existing disk to the new disk whenever the disk quorum changes. So if you fire the rebalancing with only one worker process, it will take more time to do rebalancing. But the IO impact is less. People will not see any IO impact. Well, there's only one process, it will take its own sweet time to complete that rebalancing activity, but only one process. If I say 10, the time to accomplish that task would be less, but IO impact would be more, because 10 processes are simultaneously migrating the data from the existing AUs to the new disk. So it's the choice between speed and performance. So what do you want? Do you want to see higher speed with a degraded IO performance, or you want lesser speed with an increased throughput? Isn't it? So it's a trade-off between how you want to do that rebalancing activity. So ASM instance otherwise has regular background processes such as dbwn, smon, pmon, ckpt and lgwr. But they rarely do anything in the meanwhile except for maintaining the metadata. The true working is by either rbal process or arbn. Rbal is just a coordinator, while the actual worker processes are arbn. Coming back to the next one, ASM disk group is another parameter where you mention comma separated disk group names. Now whenever you have one single ASM instance can manage multiple disk groups, and that each disk group can have its own style, such as external redundancy, normal redundancy or high redundancy, depending on how you want to run it. One ASM instance can manage multiple disk groups. Now when you start an ASM instance, only those disk groups are auto mounted, which you list here as part of the parameter value ASM disk group. Assume that I had these 3 disk groups. I don't want to auto mount arcdg. I will not put it as part of this parameter. So out of the 3 disk groups that my ASM instance is managing, only 2 of them are auto mounted. If I want to use RDG, I will have to mount it using commands. By saying alter disk group name, mount all, or only saying mount. So all those disk groups which you want to auto mount as part of ASM instance startup process should be put in as part of ASM disk group parameter. Only those disk groups which are mounted are available for the end users. Those disk groups which are not mounted, other people cannot refer to that disk group because it's kind of an offline state. So although it is created, I don't want to make it available, so I never mount it. Those which you don't want to auto mount, you don't need to put it as part of ASM disk group parameter. ASM underscore disk string is a pattern matching string which is platform dependent value as to where to locate the raw devices. Now when it comes to creating a disk group is made up of raw devices. Raw devices are located in a OS specific location. We saw in case of Solaris, the raw devices are located in /dev/rdsk folder. While in case of AIS, it is in dev folder. While in case of Linux, if you use raw devices, the raw devices will be in the folder dev raw. Now where exactly should ASM go and find candidate raw devices which can be part of your raw disk or your ASM disk group? So it's the wildcard pattern matching string as to where should ASM go and look for raw devices is that string. It will be a platform dependent value. The only portion of memory an ASM instance has is large pool. There is no other memory allocation for ASM instance. We do not have database buffer cache, you do not have redulog buffer, you do not have streams pool, you do not have Java pool, you do not have shared pool, you do not have any miscellaneous memory allocations for ASM instance. The only memory allocation required for an ASM instance is large pool size, and a typical value of 12 to 24 MB is generally more than sufficient. So if you compare the SG of an ASM instance to that of an RDBMS instance, it is very, very small. So the only memory allocation is the large pool. And a typical value of 12 to 24 MB is more than good enough for an excessively busy ASM instance. You don't need more than this. A typical parameter that you may like to put is ASM instance or instance name as plus ASM. These are only the limited set of parameters that are available with an ASM instance. You don't have any other parameters. These are the limited set of parameters. Now, the other thing, ASM instance does not have control file, data files, redulog files. It does not have anything of its own. It's only a set of background processes and a minor memory allocation only to manage data on a disk group. Otherwise, ASM does not have anything of its own. It does not have a control file, it does not have a parameter file, it does not have a data file, it does not have a redulog file. So an ASM instance can go only till mount state. There is no open state for an ASM instance. So the only state an ASM instance can go is till the mount state. And mount is different than the mounting of RDBMS instance. This is how we do things in case, or how things happen in case of an RDBMS instance. It reads the parameter file, it allocates memory, starts the background processes, and you say that your instance is in a no mount state. Then one such parameter that it reads is control file. It reads the contents of a control file, and once the control file is completely read, you say that the instance is in a mounted state. Actually, when it does so, it also applies a control file on queue lock so that no other instance should use this control file. And that's what we say, that an instance has mounted the data by applying a lock. Now there is no such thing available in case of an ASM instance. ASM instance is just a collection of disk group, and that disk group is made up of raw devices, and each raw devices has metadata. ASM instance otherwise does not have any other control file. It does not have any data dictionary since it does not have any data. So at the max an ASM instance can go is still the mount state, and mounting is different. It does not read control file. It does not apply a control file enqueue lock. It here instead reads the metadata available in the disk and it mounts those disk groups. That is how we say that ASM has been in a mounted state. So mounting of an ASM instance, meaning mounting of the ASM disk groups is what it means.
Store that metadata file, got to have some.
No, it stores it on the disk itself, participating disks itself. It stores that metadata. It is called as PST. PST. I will get back to that. So that metadata is called as PST, partition and state table, is what it is called, that metadata. There are internal utilities provided by our Oracle which can dump you that PST data. No, it's only meant for those who have ample time to study beyond the basics. Those utilities are internal to Oracle, but they can dump you. The utility name is kfed. Kfed internal utility can dump disk metadata. But we don't use it. This is only for those who want to go beyond the basics to the internals to see what exactly Oracle is doing with those raw devices. We are not often bothered about this kfed utility. Since ASM instance does not have a data file, it cannot go to an open state. But ASM instance does have a sys user. Normally, in case of an RDBMS instance, how do you change the password for a sys user? We say alter user sys identified by some password. In that RDBMS case, the user is stored and his password is stored in an encrypted form in the data dictionary. The table is user dollar. It's stored in a base table. But here we are talking about an ASM instance which has a sys user. Sys user also has a password in case of an ASM instance which we normally give during the installation, but it does not have any data file. So the ASM instance sys user is password file authenticated. So the sys user in case of your ASM instance implementation is password file authenticated. So the only way to change a password of a sys user is to delete your existing password file and recreate it using Ora pwd command. So not to say it is categorically, but now since ASM instance sys user is password file authenticated, meaning remote sysdba login to ASM instance is possible. So remote sysdba administration of an ASM instance can be done because anyways the sys user is password file authenticated.
But the fashion in which we add or resize the data file in normal sentences, SQL statements. It's the same.
It's the same way. It's the same way for us. Is this clear? Now, shutdown. Same traditional methods of shutting down an RDBMS instance are also available with your ASM instance. Shutdown normal, shutdown transactional, shutdown immediate, and shutdown abort. While the first three are graceful ways of shutting down, last one is the final resort, the ultimate method of shutting down. Now when you try to shut down an ASM instance, ASM architecture is a client server architecture. So ASM works as a server counterpart, while RDBMS works as a client. So ASM offers the storage services which your RDBMS as a client uses those services. Is a kind of a client server architecture. Not to mention it, but still I would mention it since we are putting it as part of our documentation. You cannot shut down a server when there are associated clients. So if you try to shut down an ASM instance which has running RDBMS instances, you cannot shut it down using shutdown normal, shutdown transactional, shutdown immediate. All these three ways of shutting down will error out saying there are connected RDBMS clients to this ASM instance. But if you are anyways so crazy about shutting it down, you can always do it with abort command. In which case, associated RDBMS instances will also be aborted. The subsequent time, when you try to start up after an abort an ASM instance, there is no recovery required for an ASM instance because ASM instance does not have anything of its own. But if you try to start up an RDBMS instance after a shutdown abort of an ASM instance, that RDBMS instance would require a crash recovery. You don't need that crash recovery for an ASM instance. However, RDBMS instances would require a crash recovery. You need not worry. S1 will take care of doing that crash recovery automatically. But for an ASM instance, there's no crash recovery required. But there's always a abrupt way of shutting it down, and that you can shut it down using shut abort. Clear? I'm going to put a pause on this video. We'll resume back. Welcome back after the break, and we'll start off with this time with understanding some of the other aspects of your ASM, and then we'll move on to the actual practical stuff. We'll configure an ASM instance in a non-rack environment. In case of ASM implementation, we'll see different methods of implementing ASM. There are three so-called commonly used method for ASM. We'll understand the steps and then we'll talk about each one of them. For Unix platforms, using raw devices. This is how we typically implement ASM. Create or identify the raw devices. Install the ASM software, which is nothing but the Tenji R2 RDBMS software for us. Create an ASM instance. Create ASM disk groups using the raw devices. Once you have the ASM disk group, start using it. Although you can use that method 1 for Linux as well, but the best implementation, best practices would suggest, especially for Linux, approach second, where for Linux platform, the raw devices are deprecated, we will try to use block devices. So this is what you need to do in this case. This time it's with block devices, as we said. Install ASMlib software. Once ASM software is installed, we will create an ASM instance. Once an ASM instance is created, we will create ASM disk groups using block devices and then start using the ASM disk group. Now there's also another method, but this is only for small office, home office, or for lab environment. Using fake raw devices. Once you create the loop disk devices, create raw devices for each of your loop disks, install ASM software, create an ASM instance, create an ASM disk group using raw devices this time, and start using the ASM disk group. So these are the variety of different methods using which you can configure ASM. So on all other Unix platforms where raw devices are supported, you will be following method A, although method A also applies to Linux. But best practices suggest that since Linux has a deprecated support for raw devices, you implement the ASM concept using ASMlib software. For small office, home office, where you do not have multiple raw partitions, raw disk devices, you just have enough disk space to simulate ASM, then instead create zero formatted files. Present these zero formatted files as if they are loop disk devices. Once you have loop disk devices, You can create raw devices out of them using raw binding, install ASM software, create ASM instance, create ASM disk groups using those raw devices. Now they are fake raw devices, by the way, and then start using ASM disk group. So we are going to look at first method 1 using the so-called traditional method of raw devices using Linux. Although we say Linux has deprecated raw devices, that doesn't mean you cannot create, you can create it, but raw devices service would handle it instead of kernel providing a native support like in case of AIX or like in case of Solaris. Before I go with this one, we need to understand how are we going to create, set up or identify those raw devices. First, let's get acquainted with the platform on which we are trying to do this one. So let's get familiar with the type of setup that we are running. So this is the server where we are trying to do this practical. It's oratenggvm.oracleexpert.com is the name of this server. uname-a figures out what kind of a kernel that we are using. The kernel version is 2.6.9-78 Enterprise Linux SMP for symmetric multiprocessing. The IP address of this box is 192.168.0.180. The version of Linux that we are using here is, it's called as a Red Hat clone CentOS release 4.7. Now we are going to implement first raw devices. Raw devices in case of Linux are established first by identifying which disk devices you want to use for this purpose. I don't know what all disks we have. I identify them by saying fdisk-l grep caret disk. There I can see that these are those disk devices which does not have any partition created as of now on them. Each of these disk device that we plan to use for our ASM purpose is approximately a 10 GB disk. For the first method, I am going to make use of device/dev/sdb. Since there's no partition, the first thing I want to do is to partition that disk. So I use fdisk/dev/sdb to partition it. It takes me to the fdisk prompt where I see print the partition table. There's no partition as of now. I say new primary type of a partition, partition number 1, starting cylinder number and the ending cylinder number. I have accepted the default value. I say print it now, and this is the only available partition on disk. Name of the partition is device name dot partition number. Device name and partition number. So device name is SDB, and since we are talking about the first partition, the name is SDB1. I save it and quit. This will write the partition table back to the disk. Once I synchronize, I need to reboot so that my OS should understand the partition that I have created, because OS kernel would read the disk partition only at the time of boot. So until I boot it, my OS is not going to identify this partition. A shortcut available these days to do the same thing is to say part probe followed by the name of the device. So kernel is forced to reread the disk partition table afresh since we have created a partition. Now if I see what kind of a device is this, it says that it's a block special device. What we want to implement this time is using traditional raw devices for our ASM implementation. So I need to establish a raw device via a process called as binding. This is only applicable for Linux, where Linux does not create by default a raw device name for each of the connected disks that you have. Now once I have this disk partition with the name /dev/sdb1, I need to establish a raw partition by using raw command. I don't know the syntax, I would simply type raw. So the command would be raw /dev/raw/raw1 and to which block device it should point to. The moment I hit it, it says now you have a device called as raw1, which is bound to a major device number 8 and minor device number 17. This is that major and minor device number. So the Unix identifies each device treating the device as a file and each device as a major and a minor device ID. So the major ID for this device is 8 and the minor number is 17. Now via a process called as binding, you have bound a raw device with a block device. Now if I say ls-l of both, I see that the raw device is created with the first character as C, which indicates it's a character special device, which also indicates it's a raw device, which also means it performs an unbuffered I/O. While /dev/sdb1 is a block special device, a traditional disk which uses I/O buffers, kernel I/O buffers while performing I/O. ASM, however, would need a raw device for a traditional implementation method A. Now once this raw device is established, you would see two things are predominant. Number one, the ownership is wrongly set to root disk, which will happen every time your machine would reboot. So I must change the ownership back to Oracle O install, who is going to be our user for ASM implementation. So I need to change the ownership for this disk to Oracle DBA, because Oracle is member of DBA group in this case. So I would change the ownership, saying change the ownership for that raw device to Oracle DBA. I check it after this. Now the raw device is being owned by Oracle, while the block device equivalent to which this raw is bound to is still being owned by root. This is always mandatory, otherwise your ASM cannot see that raw device if the ownership is not with Oracle. But the problem is, every time I restart my machine, two things would happen. The binding will disappear, and if I recreate that binding, the ownership will again get back to root disk. As a quick thing, I would show you. I say service raw devices restart. If I do that, I check it again. As of now, looks like there's no restart happening. I say that by saying service raw devices stop. It's not giving me anything, so I'm suspecting what's happening in the background. But as of now, I don't see that thing happening. But every time if I reboot, this file will disappear. And even if I create it again, the ownership will again get back to root disk. So I must make it persistent so that after reboot, the raw device binding should auto create itself and that the ownership should reset back to Oracle DBA. For Red Hat release 4.x, or for simply saying for a kernel release 2.6.9, the file is etc sysconfig raw devices, where you should put that binding. So I am going to put that binding here by saying this raw device binds to this block device. I am going to copy the same command except for the raw command part into this file. I just add a fresh line to this file saying my raw device dev raw1 is actually bound to a block device dev sdb1. So every time my machine reboots, this binding will automatically be there. Okay, this has addressed only the binding part. The ownership is still not being taken care. So the binding will be there, but the ownership will still be with root disk. So to address this one, I put a command for change ownership in etc_rc.local. Contents of your rc.local are executed after every subsequent time your machine reboots. The contents would be executed. I simply added change ownership to Oracle DBA for the raw device. So two things I have provided for through etc sysconfig raw devices. I ensured that every time my machine reboots, the binding is in place. And by putting the change ownership command into etc.rc.local, I ensured that every time the raw binding recreates, the ownership also is transferred back to Oracle DB. So now the raw devices are in place. So what we have achieved as of now is we have created, identified and set up the raw devices part. The next thing is to install the ASM software. So we'll install the regular RDBMS software. You may have a choice here. You may like to install in its separate Oracle home, or you may like to use the same set of binaries for both ASM and for RDBMS instance. Although the best practice always suggests that you run ASM instance from its separate Oracle home and RDBMS instances from its separate Oracle home, to save time and space, I am going to run it from the same Oracle. I am switching back my identity to Oracle. I want to see where my software is staged. Once I locate it, I would try to start using that thing. So I'm trying to locate where from I can bring in the Oracle binaries, and once those binaries are available to me, I would start using them. As of now, I do not have any software staged, so I want to use the staged version. I need to locate where the stage in my network is. I'm going to put a pause on this video until I locate where my software is. Once it is located, I will tell you how to access it. On one of the Windows machine, I could locate in my network the software is available. So I'm going to create a mount point, and I'm going to try doing a Samba mount to get that software mounted on my local machine. So I can see that now it's mounted here. So I go to /bin, and there's a lot of softwares available there. I'm interested in the RDBMS software. So this is from where I should be launching my installer. I open another session as Oracle user. Once I do that, I will move on to that directory where my RDBMS software is available. Once I go there, I'm going to launch the run installer. This is no different than your regular RDBMS software installation, although as I said, best practices would have suggested you installing ASM software for running ASM instance in a separate Oracle home than you doing in the RDBMS part. Once this OUI, the Oracle Universal Installer is there, I'm going to go for an advanced installation. I'm going to put my Oracle inventory, central inventory. Since I didn't set Oracle base, I will have to explicitly change the path. U002 app Oracle Aura inventory. This is the owner of my Aura inventory in this case. I'm going to do an enterprise edition install. Would identify that Oracle home as 10G RDBMS, and I would like to install it under U002 app Oracle product 10.2.0. Since I am going to use only one common home, I am not further saying DB or AS. So following the OFA, I am going to use the so-called common Oracle home for both running my ASM instance as well as for running my RDBMS instance. But best practices would always suggest you doing two different homes. Apparently it's not happy with something about my network setting. So I'm going to look at it says looks like you are assigned a DHCP based addresses. I need to correct this behavior. Although Oracle can be installed with DHCP based servers, I'm more worried about as to why it thinks that I'm not using a static IP. So I need to check. I'm going to cancel this off for the time being. I would correct that why it thinks that I am using a DHCP based addresses. So here's my small toolkit. It expands a nice little thing, my network configuration. I would have done it through command as well, but I want to see why exactly it thinks that I am using DHCP based addresses. Although I am not using DHCP, I have assigned a static IP address. So I can ignore that warning. I can go back and backtrack as to why it thinks I am using a so-called DHCP based addresses, but I am not using one. I need to check what is my host name, and this is my DNS. I don't know why it's thinking that I'm using a DHCP based addresses. I will try to correct the behavior. I open my etc host file. Probably there's something missing here which is causing that issue. Yes. I'm putting the exact IP address that it should have been here. This is what my host name is. And it can ping it now. I'm going to launch that installer one more time. Although I could have finished that installer no matter whether it uses DHCP or not, I wanted to go and correct the behavior. Although we assured that we are not using DHCP based IP addresses. Location of my central inventory. The enterprise edition install, the name of my Oracle home as I would like to. It says warning about incompatible Oracle home because from my previous install it might have placed a couple of files in there. I ignore this warning, I still want to proceed. This time it says 0 requirements to be verified, so it's apparently happy with my setup. This time I just want to do the installation of the software because I plan to upgrade that software to the latest patch set I have. This will install the vanilla 10.2010 installation 10G release 2.
Chosen ASM.
No, we are not planning to configure ASM. We'll just install the software. We'll upgrade it to the latest patch set that I have, and then we'll launch DBCA to configure ASM. Once we have this installation done, it's going to ask us to run root.sh from the Oracle home that we have. Since that installation is progressing somewhat with a slower speed than is expected, I'm going to put a pause on this video until there's something significant to record. It's almost now about to complete the installation. It has copied the file, it has relinked the binaries, necessary setup has been done. Now it's asking me to run those two scripts. One is ora-inst root.sh to set up the inventory permissions, and once that's done, it's asking me to run root.sh. It'll ask me where is my local bin directory. Once I do that, it's going to change a couple of files permission. It's going to change put certain scripts in user local bin, and once I am done with this, I can put an closure to my installation. Once I have done both the scripts, I am saying OK. What I have is now Oracle binaries of the version 10.2.10 installed under the given Oracle home. Next is to apply a patch to it. So I get the latest code set. The patch that I have, although is not latest one, but I have 10.2.0.30, which I am going to apply to my Oracle home. I have selected our Oracle home where we want to apply this 10.2.0.30 patch set. In the meanwhile that it is working, we'll also set up the environment files. We have created two files, one for setting up your RDBMS environment and another is for setting up your ASM instance environment. Both of them are pointing to the same Oracle binaries. Currently I will set the environment for my ASM purpose. Once, however, the patch is applied, we'll try to configure ASM instance. What we need to know in the meanwhile is when you try to configure an ASM instance, while configuring an ASM instance, it requires a daemon to be up and running. The name of the daemon is OCSSD for Oracle Cluster Synchronization Service Daemon. So when you try to configure an ASM instance and it finds that you do not have OCSSD up and running in the background, it would complain and it would suggest you that you run from your ASM Oracle home bin directory a command called as local config -add. Now what this local config add command would do is it will create a folder called as etc oracle. It would place a file in this folder called as ocr.loc, and in this file it will add 2 lines: ocr location and local only is equal to true. Now local only is equal to true is because we are talking about a single node ASM implementation. In case of a cluster also has the Oracle cluster registry, but in that case local only parameter would be set to false because we are talking about a clustered environment. And somewhere down the line under your ASM Oracle home folder, you would see the location for your OCR, which I am going to add after we run a local config add command. Let's get back to your installation. It's still on that installation part. It's applying 2 one-off patches as part of that patch set 2 to your RDBMS Oracle home. Once we are done with that, we'll start off with the DBCA part of it, which will configure ASM instance for us or ASM environment for us. So somewhere down under ASM Oracle home CRS public folder localhost, it will keep the OCR file. This is the metadata of your metadata used by your OCSSD daemon. And once we configure ASM instance, once we are attempting to configure it using DBCA, we'll move further towards the ASM instance configuration. It doesn't take a long time to start ASM instance. Finally, we'll then configure, once we have an ASM instance, we'll then configure ASM disk group, and for this purpose we plan to use dev raw1. You can find it out which raw devices you have by saying raw-qa. So it shows that currently you are using dev raw1, which is bound to a major device number 8 and a minor device number 17. You can check it which is that major and minor device number. So it is bound to /dev/sdb1. Here we are, it's asking me to run root.sh again one more time from the Oracle home. Once I do that, I would get back to my installer. Now what I have is an RDBMS Oracle home of the version 10.2.3. Now that we have already set up an environment here, if I say env grep oracle, it already talks about the so-called ASM environment. Now if I say which DBCA, it points me to the correct DBCA. I launch DBCA. This time I am going to select the last option, which is for configuring automatic storage management. And here it complains me about that you do not seem to have OCSSD daemon running. You should run local config add as a root user. I get back to my root users prompt. I do not have any CSS process running. Neither I have etc Oracle folder. I am going to run u002 app oracle product 10.2.0 bin local config add, and this will do the rest. So it would configure etc Oracle folder with ocr.loc into it, and it would also start the cluster synchronization service.
This daemon CSS is different from the CSS that we have in RAC.
Yes, it is different. The CSS daemon in case of rack runs from cluster Oracle home. Here it runs from the ASM or RDBMS Oracle home, whatever is the case.
So in case if we have both RSC and ASM.
No, it would be only running from the cluster Oracle home in that case. That's it. We are running. We go to cd etc Oracle folder. What I have is ocr.loc, and ocr.loc has a ocr configuration, the cluster registry in Oracle home c data localhost local.ocr. So I see ls-l, I see that cluster registry here. Local config saying it's true, that means we are talking about a single node ASM implementation. In case of a cluster, it would be local config equal to false. I get back to my installer. I click on to the OK. Now again I hit the next button. This time it has no problems. It asks me what should be the sys password. This is what we were talking about some time back. Although we have sys user in ASM, the only way is to have this user is password file authenticated user. Here I can check a couple of parameters for ASM. We talked about ASM disk group, disk string, and ASM power limit. I'm not bothered about it as of now. I'm just going to give a simple password for as welcome one for sys user here. And it says you do not have an ASM instance as of now. Do you want me to configure one for you? I said yes. That's it. ASM instance is up and running. What we do not have is disk group configured as of now. So here from I say configure a disk group for me, and automatically it has detected that there's a raw device. Status shows status as candidate. Now let's spend some time understanding the status. So when you go to the disk group addition screen, it talks about the disk status, which could be candidate, which means a fresh disk is available to be added to ASM disk group. So here I get back. So there's a fresh disk available, has not been used so far anywhere. That's why the status shows as candidate. Status might show you as member, meaning the given disk is already part of some ASM disk group. Status might show you former, meaning the given disk was earlier part of some ASM disk group, but now it is available. That's why the status former. Status would show you as foreign if the given disk is being used by some other software other than ASM. Status would show you as provisioned if you have stamped, if a given disk is stamped on Linux platform using ASMlib software. So provision status you would only see in case of ASMlib based implementation. Otherwise you will never see a provision status. When we do the same implementation going ahead with ASMlib software, that time we will see the disk as provision. So these are the various status of the disks. I get back to the disk group creation wizard. The disk group name, I call it as data.dg. What type of a redundancy is desired? High redundancy, normal redundancy, external redundancy. Now since we have only one disk, we do not have a choice but to go with external redundancy. But if you choose to go with normal or high, you need to provide the subgrouping, failure group names. I would have provided FG1, FG2, FG3, so on, depending on whether I want to do a normal redundancy or high redundancy configuration. This time I am going to select it as external redundancy. Automatically the failure group column will disappear. Because with an external redundancy group, there is no subgrouping within a ASM disk group. The disk size is 10 GB, and this is the disk that I want to add, and that I want to add it as a short name D1. I want to add this disk as with the short name D1. So going ahead at a command prompt, I can refer to the disk either with a short name D1 or with a more elaborated name dev raw. So it's kind of a disk alias. If I would have selected normal, there comes a failure group column. If the status shows anything other than candidate, like in this case, let's say my disk status is showing status as member or status as foreign, there would be an added column here which says force add the disk. So you can forcibly add a disk provided the status is member or status is something else, foreign. So then I can forcibly add it, but I want to add this time using an external disk group redundancy factor. For my disk group data.dg, I have added raw1 with the short name as D1. Once I add it, it will show that the disk group is mounted. The same thing could be achieved using a command line as well. It shows that the disk group is now mounted. It's of the type external redundancy of this size and the available space and the name. Once I am done, I say finish, get back to my command prompt. I would cancel this one so far. I get in as Oracle user. I set my environment to ASM environment. I say ps-ef grep ASM, and I see all the background processes running there. So you have regular background processes. What is of some interest for us is rbal, and we do not have any ARB processes as of now. I go to the Oracle home DBS directory, and we have this as our parameter file. You can log on to SQL star plus. Our Oracle CD is set to plus ASM, by the way. So I am connected to an ASM instance. I say from select star from ASM instance, $V instance, and it shows me that my instance is of the name plus ASM. It is of this version. It's running on this host, and currently it is up and running. Every now and then I often struggle to set the page size and the line size, so I'm going to make a permanent modification. I go to glogin.sql file, I add set pages 1000 and lines 132. I get back to my ASM instance. I say select star from $ASM disk group, and it shows me there's a data.dg and the details about the data.dg. I say select star from $ASM disk, and it shows this is the raw disk, which is abbreviated as D1 in my configuration. I can use regular commands on ASM instance such as create disk group, alter disk group, and drop disk group. So you can create a disk group from a command line, you can alter an existing disk group, you can drop a disk group, you can add new disk to an existing disk group, you can drop an existing disk from the current disk group. All these operations can also be done using command line, using SQL star plus prompt. What we do not have as of now, I believe, is the listener. I am going to configure one for us. I'm going all with the default configuration. I'm configuring a default listener to run on port 1521 using TCP as the protocol. So my listener is up and running on port number 1521 alone as of now. And that I have my ASM instance dynamic service registration happening with that ASM instance, with that listener. My ASM is identified. Next thing is to create the database which stores its files onto this ASM instance. So I launch DBCA one more time. This time I would start with the database creation operation. I'm going to select a templatized database. Nothing fussy about it. I'm just going to create a regular general purpose database. Name of my database, as we set in the environment file, is prod. I do want to configure enterprise manager. Make sure you have appropriate licenses before you configure enterprise OEM. I'm going to keep as the common password welcome one just to help me remember it easily. This time, however, on the storage point, I configure it with ASM, saying I do want to configure it, but this time using ASM. It says, what is your ASM sys password? It's welcome one in our case. And it says, this is the disk group there. I said, okay, select this disk group. I would like to place my files here. I selected use Oracle managed file OMF feature. And this is my disk group so far. Before I go and do anything else, I would get back to my command prompt. There's another interface that ASM provides you, that is command line access using ASM CMD as the command. Once I type ASM CMD -P, it takes me to the ASM command prompt. Here I can use a couple of supported commands. This is not a LS command of your operating system. It's the LS command of your ASM CMD. I can see that there's a mounted of the type external redundancy, a disk group called as data DG. I can go to that data DG. It's just an illusion. It's not a true interface. It's just an illusion. So far I don't see anything inside it. Some of the commands that are supported are lsdg to show your disk groups, lsct to show all the connected clients. So far there is no connected client. Never press Ctrl C here. If you press Ctrl C, you will back to, it's like terminating a running program. So come out by saying exit. We'll see sometime some difference. I get back to my installer, the DBCA wizard. I do want to configure a flash recovery area under the same disk group. I want to enable archiving. I do not want any sample schemas, the rest other things at default. What is here is, you see the data files as OMF. So names will be entirely driven through OMF feature. Now I want to create the DB. So let it create the database in the meanwhile.
Is it mandatory to choose one?
No. There are certain added benefits because of you selecting Oracle managed files. Number one, your commands can be really short. Assume that I want to create a table space. We traditionally would have created by saying create table space test data file u008 ora data prod test01.dbf followed by size 100M auto extend on next 10M max size whatever unlimited or 8 GB whatever is your way of putting it and so on. You might have kept this is also called as the default sizing factor. But now that you are using ASM, the same thing can be achieved by saying, now since there's no file system, I would say, and that now I am using OMF, I need not even say data file. Now my command can be as simple as this one. So if you want to mention which disk group, you can say data file into single quote, name of that disk group. If you don't want to mention because now you are using OMF, your command can be as short as create table space name. In this case, the default sizing clause would apply, and default sizing means size of a data file is 100 MB by default initially. Auto extend is set to on to an unlimited size of 32 GB. Extend extents are managed locally with a uniform size of 1M. Segment space management is auto by default. If you however want to mention a different disk group name, you have a choice. You can mention it this way. In short, with OMF, you can say only create table space name. Since we are using OMF also for our redo logs, to add a new redo log group, you could have said that's it. You need not mention any members, you need not mention any file specification because we are using OMF feature. I get back to our DB creation, it's almost to some level. In the meanwhile, I get back to my ASM command prompt by saying ASM cmd-p, I say ls-. It shows me data DG is there. Inside data DG now there's a prod folder, which is name of my database. I go to prod, there are a couple of folders, data file, control file, online redo log file, temp file and so on. I go to data file and I say ls-l, I see all OMF names.
So under that,
yes, it creates it under a specific directory. So under a given disk group, whatever is the name, in our case it's data DG, it creates the name of the database, and inside that it creates data file, control file, and then it keeps file names as system.x.y, while x and y are auto generated numbers to ensure that OMF creates unique file names. In the meanwhile, let's see the help command. The only supported commands on ASM CMD prompt are cd, du, find, help, ls, lsct, lsdg to create an alias, mk alias, create a directory, pwd, rm alias. These are the only supported command, meaning cp is not supported. So the only way to take a backup of your RDBMS which stores its file onto ASM is rman. You cannot do a manual back. Yes, it's all an illusion, nothing more.
so is it putting some security also.
No. It's just to give you a pictorial representation to get you comfortable onto what is there in the disk group. Finally, we only have raw devices internally. So raw devices does not have any directory. Raw devices does not store multiple files. They do not have an inverted directory tree like structure. So it's all an illusion. So it gives you an illusion tool using ASM CMD. You can see exactly how things would have been internally. But actually, internally, this group is made up of raw devices, and that raw device has only one file, and that the file is ASM file. Whatever is stored in the form of AUs goes as part of the contents of that file. So there is nothing called as a directory, there is nothing called as a file. It's all an illusion via ASM CMD.
In this example, stripping is not taking place because we have only one disk.
Yeah, in this case, yes. But this wouldn't be the case in real life. I just wanted to show you the ASM part. So when there are multiple disks, data would be striped across all the disks in a disk. Here we go and see that the database instance is up and running. Now I'm primarily interested only in the background processes. These are the background processes, and one such background process is ASMB, which stands for ASM bridge. Now this is a foreground process using which your RDBMS instance communicates with your ASM instance. So this ASMB is a background process for your RDBMS instance. So the moment you see ASMB process for one of your RDBMS, it means at least one file of that RDBMS is being stored onto ASM. Now if you are not too happy with simple things, don't content you, then in that case, you can have a couple of files of your prod database under a file system, say U008, some other files on raw devices, and some other files on ASM. But nobody would like to do this insanity, isn't it? It's an insane behavior. But technically speaking, yes, all of them are possible. Here's my database instance which is up and running, and that the OEM and database control has been configured on this port. I'm going to just come out of this one. My DBC has finished in the meanwhile. And here I am. My prod database is also now dynamically registered with my listener. I set the environment to my RDBMS. I log in to my RDBMS instance. So I'm talking about the RDBMS instance prod. So I'm currently connected to prod. This proves that all my data file, control file and everything are there on the disk group data DG. Clear? To create a table space, now I can simply say create table space test. It would automatically strike my data file. It will automatically name it because of OMF feature, and it will automatically place it onto all the raw devices that are part of the disk group data DG. By OMF, I mean that you are using db create file test, and db create file test is pointing to your disk group data DG. I say show parameter sp file, and it says that sp file is also onto the data DG. Clear?
Whenever we create a table space, what about the size we are giving?
Default sizing, as I said, where data file is of 100 MB, auto extend onto an unlimited size. Extend management is local, extend size is uniform of 1 MB, and segment space management is auto. When you don't mention, default storage clauses would apply.
What if we have more than one meeting group?
You have a choice to keep your files onto all of them.
No, will Oracle itself manage it on that?
No. It all depends on what parameter value you have set for db create file test. So currently it is being set for data DG. So if I create any file, it will be stored under data DG. Assume that you want to store it elsewhere, change that parameter first by saying alter system set db create file test 2, and later on create a file, it will go to new DG. I launch the browser and we would go back to that URL for DB control. Here I am with the browser open. I log on to DB console as sysdba. There's a license agreement. You must do it knowingly that it requires separate licensing. Here I am onto the home page of my database control utility. Here it shows that I am using ASM. If I click here, it takes me to the ASM home page. And this is my disk group data DG, although it doesn't have a graph populated as of now. Sometime down the line, you will see that graph is filled up. I go to the administration part of it. It says log into your ASM instance, logging in as sys user. This is my disk group data DG, and this is the used space. I can perform all the operations that otherwise are possible using command line, can also be done via DB console. I can mount, dismount, I can manually fire a rebalance activity, I can create a new disk group, I can mount all or dismount all, I can delete them, I can check what is the configuration of my disk group. And here it shows that your disk group has 87% free space, 12% of it is being used by prod, and remaining 0.05% is for your metadata. There's only one disk as of now in this one. Short name is D1, long name is Dev raw1, and the state is normal, and this is the usage. Those graphs are populated once the significant data is collected. I'm coming out of it because it's the GUI way of doing things. Now, what we have to see here is how is my ORATAP file looking like. Now ORATAP talks about two instances plus ASM, which is running from this Oracle home, and prod, which is also running from the same Oracle home. Now this is the method using pure raw devices, although Linux does not support natively raw devices. I'm going to dismantle this setup and then we'll see the other best practices method using ASMlib. So I'm launching DBC, I'm going to dismantle the whole database off.
ASM with raw, we can still exploit the non-buffered algorithm.
Yes. This time I am saying delete a database. And I am selecting prod as the DB. I am going to dismantle of the prod database. Once I am done with that, I am going to also drop the disk group.
So deleting operation has to be done through DBC only, right?
No, you can remove it. Yeah, in case of ASM that you have some of the files there, it's good to do it with DBC. Once it deletes this database off, I am going to remove the disk group also, and then we'll see the alternate method using ASMlib software for configuring ASM, where we'll be using block devices for using ASM, to be used with ASM. Now it says the database delete operation has been completed. I am coming out of this DBCA, no more database now. Once the DB is being deleted, I am going to log on to my ASM instance. Although the database is deleted, there are still some open directories there. So if I say drop this group data.dg, it says you cannot drop it. I must drop it by saying including contents. This group has been dropped. Now, although I have that raw device, I am not going to use it. This time I will configure ASM disk group using block devices using ASMlib software. To download ASMlib software, you need to go to the Oracle's website. You must know beforehand what is the kernel version, because those software RPMs are kernel specific. Then I already downloaded them. I go to ASM RPMs folder and see everywhere they are matching to my kernel version 2.6.9-78 ELSMP, which is Enterprise Linux Symmetric Multiprocessing. Once I download these RPMs, which primarily comprises of ASMlib, Oracle ASM support, Oracle ASM kernel specific version, I install them by saying rpm-ivh, all of them. So this would install all those RPMs. Once all of them are installed, what is there on my machine now is a script called as Oracle ASM. This Oracle ASM script allows me to start, stop, restart, enable, disable, configure, create this, delete this, query this, list this, scan this, and check the status. These all activities can be done using my Oracle ASM. There's also a device folder created called as Oracle ASM. Oh, I haven't configured it yet. So the first thing is to, one-time job is to configure your ASM. So run it with this command and configure option. It's once in a lifetime for a given machine. So I configure it by saying init.d Oracle ASM configure. It asks me as what user should own this one. In our case, it's the Oracle user. Who is the owner group of that particular thing? In our case, it's DB. Do you want to start the ASM library driver on every boot? We said yes. Do you want to scan for the disk, candidate disk every time? I said yes. That's it. One-time configuration task is done. Now I see what it has done. It has configured a directory called as dev Oracle ASM, in which you have disks as one of the subfolders. I go to dev Oracle ASM disks folder. As of now, there are no disks. Okay, let's start using one of our existing disks for ASM purpose. I say, show me all the disks that I have. Now you know that SDB1, we have used it for raw purpose. What we have apart from SDB is SDC, SDD, SDE, SDF. Now I'm going to use 3 disks as block purpose. We'll use it. So I'm going to first create partitions on them. SDC, there is no partition table so far, no partition. I create new primary partition, first partition, starting and ending cylinder with the default values, save and quit. Similar way, I will create one more for SDD and SDE. We will use 3 disks this time. I say do the same partitioning for print. There's no partition. Create a new partition of the type primary. Create partition number 1, starting and ending cylinder number, save and quit. I'm going to create one more for SDE. There's no partition so far on this disk. I said new primary first partition, starting ending cylinder number, save and come out. Since my kernel would be unaware about any new partitions that I have done until I reboot it, I must do part probe. Now I check. See, these are the partitions. What type of devices are they? They are all block devices. This time we are not going to change them to raw. Instead, we are going to make use of ASMlib software. So I want to stamp those disks with some name. So I say etc init.d Oracle ASM create disk as the option. What is the name I would like to call them with? I want to call them as D1, and the D1 is my SDC1. It says disk is marked. Then I create the same way D2 as /dev/sdd1, and then I create D3, which is my /dev/sde1. Now I don't know how many of them I have configured. Then I say etc init.d Oracle ASM list disks. It says you have D1, D2, D3. I don't believe this. So I am into dev Oracle ASM which earlier says there were no disks, now there are D1, D2, D3. We didn't create them as raw. See here, D1, D2, D3 are still block devices. Clear? Next thing is to configure ASM using this disk. So I launch DBCA one more time. I get back to next. I go to configure automatic storage management. The disk group was dropped. This time I say create new disk group. It says there's only one raw device because it is looking somewhere else. Because my discovery path is by default set to dev raw 1. I will change it to, now that the new disks are available under the moment I do that, it says, okay, I can find them. So the disks are D1, D2, D3, status is provisioned. Clear? This time I want to add the disk. Earlier you saw that the status was showing as former. Now I will make it as data DG one more time. This time for your understanding, I'm going to select it as high. I'm selecting these 3 disks which are all of equal size. I call them as ASM1, ASM2, ASM3. They are part of failure group FG1, FG2, FG3. So although my disk group is of the capacity 30 GB, usable space is still 10 GB because one is master copy, 2 others are mirrors. I click it here. And here's our disk group. So the total size is 30 GB, but free is only 10 because only one disk is actually, disk space worth one disk is only usable. I create a database in the meanwhile. I would create the same database again of the name prod. I will configure it that ASM, that OEM thing, default password as welcome1. I select ASM. Would ask me for the sys password for ASM instance. I said welcome1. It says you have a data DG this time of 30 GB and 10 GB usable space. This is what I want to use. I want to use OMF as my way of storing on data DG. I want to enable archiving. I also want to have flash recovery area. Rest all things at default. That's it. So while it creates the database, I take you through again the command prompt of it. I go to ASM CMD command prompt. LSDG shows me that my disk group is now a slightly bigger disk group, 30 GB and 10 GB space. LSCT will show me the connected clients. Prod is your client this time. So I go to data DG. I have folder prod. Inside prod I have so far only data files because the database is being created. I go to data file and I see already 2 files are there. Now this time it is going to be somewhat slower operation because same data it needs to write 3 times. I am coming out of it in the meanwhile. I say LSNR CTL status and prod database is dynamically registered with my listener. Because my listener is a default listener, you can figure it out that it's listening only as of now on port 1521 using TCP as the protocol. So it's going to take somewhat a little longer than our earlier attempt where it was with external redundancy disk group. This time it's with high. So whatever is the data size, it's going to be 3 times what it was originally. I'm going to put a pause on this video until the operation finishes, and then we'll resume back with something really interesting. Now that the database has been created, we get back to this database. I'm going to set this environment this time for the RDBMS environment, the production database. Now there's another way of you accessing those files from the ASM CMD, from your ASM disk group. While ASM CMD doesn't allow you to do anything with those files, there's an alternate method. So I log on to my RDBMS environment and see the alternate method. Prior to that, I would like to show you the way our listener is configured. So if I say lsnrctl status, the listener is currently configured to run on port number 1521 alone. But using a new way, Oracle offers you using XDB feature two interfaces called as FTP, the file transfer protocol, and the HTTP for your web access or hypertext transfer protocol, way of accessing the files from ASM disk group. To do this, on your production database, you need to run a script called as, so do notice that so far our listener is learning only on port number 1521. We'll configure 2 additional ports, one for FTP access and another for HTTP access. So log on to the database and run a script from your RDBMS admin with the name cat xdb-dbca.sql. It will prompt you for 2 ports, one for FTP purpose, another for HTTP purpose. So it says, what is that FTP port you want to use? I type 2121. And what is the HTTP port? I say 8080. Once I do that, I check the listener, and now listener is listening on 3 ports, 1521, which is the DB connection port, 2121, which is the so-called FTP port, and the HTTP port is on 8080. Now see how we access those files on ASM disk group. Now assume that I want to download a file, whether it's an archive log or a data file, doesn't matter though. I launch using a web browser. I say http ora10gvm.oracleexpert.com port number 8080. It's a typo there. It asks me the password. This should be the system password for your database. So logging in as system and the password, it takes you to a directory structure. Go to sys, go to ASM. Here you see the data DG. Once I go to data DG, I see prod, I see data file, control file, online, and so on. I go to data files. Now the smallest one I am trying to download, which is users file. I right click on it and I say save link as. I save it on my desktop. The file is downloaded. So I log out from the browser. I get back to my desktop. And here's the file. So this is another way of you downloading files from a ASM disk group. The another method is using FTP method. So I'm going to remove this file as of now. So there's nothing so far on the disk group, onto the desktop. I log on using FTP interface saying Aura 10G VM, port number 2121. It asks me the username, which is system. System's password is welcome1. I am onto the FTP prompt. I say dir, I see sys folder. I go to sys, I say again dir, I see ASM folder. I go to ASM, I say dir. It shows me data DG. I go to data DG. Into prod folder, I go to data file. Then I say dir. These are my files here. I must transfer these files in a binary mode. I said bin. To show the hash progress, I typed hash, and then I say get name of the file. So it would download that file using FTP protocol. Once done, I say bye, and here's the file. So these are the two other interfaces available using which you can either get or put files onto the ASM disk group. So saying that the only way to do RMAN backup is partially true. So although it is the only supported method, but you can put your database in a begin backup mode and download those files using FTP, which is far beyond the reality, isn't it? How would I be doing these FTP gates and HTTP gates of files from using a production database? So that way, the only supported method of you doing a backup is using RMAN. I'm going to show you a quick way to do a backup. I go to U008 and then I start doing the backup using RMAN. I go to U008 Aura data folder. I create one RMAN_BKP. I go to RMAN BKP. This is my place where I would like to do backup. I would say RMAN target equal to / I would copy this location. Then I say backup as compressed backup set database format no more fancy things, just a very simple straightforward backup command. Here starts my backup. Here I go to the RMAN backup folder and these are the backup pieces. So the only supported method of you doing a backup from an ASM is to take a backup using RMAN utility. But if somebody wants to explore, you are free to explore putting the database in a begin backup mode and downloading those files using FTP or HTTP method, and then try to later use those files for a cloning or for doing a DB recovery. But those methods are since so-called looks like a childish method of doing those things. So the best way is to automate your backup strategies using RMAN. No. In the meanwhile, I would launch a browser to get back to our database control utility. Here it is showing me about ASM. I go to the ASM part of it. The graph is yet not populated. I go to the admin portion and the performance part of it. And these are the performance graphs. So it will get populated once we put certain load onto it. You can get IO summary, disk usage summary, and so on. I go to the admin section of it. This is my data DG. I click on it and it's made up of 3 disks this time. ASM1, ASM2, ASM3. The performance graphs are not yet populated. I will populate them every 15 seconds automatically. Then you would see those performance graphs as well. In the meanwhile, in your background, the RMAN backups is almost done. So I say list backup of database summary, and this is where your backup is. So although there's an HTTP and FTP way of getting connected, the best way would be to get your backups done is via RMAN. So far those graphs are not populated and I am also not bothered about it. So this is your disk group configuration. And these are the 2 backup pieces for your database. So using this method only, we should be doing the backups for your ASM instance. All the ASM administration can be done either using SQL Star Plus or using DB control or using DBCA. So thanks for joining in for this ASM session. This is where we would like to put an end to this session. There's another significant portion to be talked about, but then maybe at a later time. How to convert your database from non-ASM to ASM, or how to do it vice versa if you want to move your database from ASM to non-ASM. But already we are running on this 3 hours video, which is like a long running Lagan movie, 3 hours. So I'm going to put a pause for it, otherwise there would be a lesser viewers for this video. Thanks for joining.